Welcome back, friend. In this video, I'd like to discuss the last two types of bonding, namely metallic bonding and van der Waals bonding. So first, let's summarize metallic bonding. Now, in a metal, when it's a solid, the metal atoms lose their valence electrons, and that gives metals their very special properties. Right, so their electrons no longer stay local to them, but instead can move around and be shared with the other atoms. So electrons can freely move around. Now, where are they moving around? Well, of course, they're moving around where they came from, and they came from what are now positive ions, because they have lost their electron in their valence band. And this is often called a sea of electrons. All right, and this is actually similar to covalent bonding because the electrons are shared by two or more atoms. But of course, it's different because the electrons can freely move around beyond just the two that might be in a covalent bond. And as we well know, metals are good conductors of heat and electricity in general. They are usually polycrystalline, or perhaps amorphous. And usually the conduction is not directional. So there's no preferred direction for that conduction. It can conduct equally in all directions. All right. It is easier to move the electrons around, and because of that, metals can often be mixed with many other metals to form alloys. And the last property I'd like to highlight is that the energy that bind the electron to their atoms is on the order of the energy of photons. And that's important because, of course, we've already talked about the photoelectric effect, but more generally, it's important for many devices. Such as LEDs, solar cells, sensors of all kinds. So let's write this down. The energy that bind the electrons to their atoms is on the order of photon energies. And of course, what that means beyond the photoelectric effect is that these are often leading to effects where a photon might come into a metal and be absorbed, but then also be emitted very easily and be emitted near the surface. And you may not realize it, but that's why metals tend to be shiny. because the sea of electrons is able to absorb and then pretty much immediately emit the absorbed photon. All right. Last topic, last bonding type is that of van der Waals bonding. Let's summarize van der Waals bonding because it's so important to nanotechnology and many other fields, of course. All right, so this is named after Johannes van der Waals, and he was awarded the Nobel Prize. And there's three types that we want to highlight. And we can also think of them as forces. First of all, there's dipole-dipole force. There's a dipole-induced dipole force. And then lastly, there's a repulsive force. All right, but before we define this much further, I want to ask an interesting question. See if you know the answer to. How many drops of water can be placed on a penny? Maybe you think one or two. Well, and actually it's much more than one or two. And why so many? Secondly, I'd like to ask, how do geckos stick onto a vertical wall? And actually, they don't just stick, they can walk. All right, let's turn to some other videos so that we can answer these questions and understand more about van der Waals bonding.